I'm about to share my screen with you and kind of talk about what we went over in class today since you weren't there. All right, let's see if we can get it to work on a good day. Let's try it. Okay, here we go. We didn't really do a lot new. We really kind of spent a fair amount of time reviewing what we went over on the video from Friday on functions. So make sure that you do look back over those. You know, functions means one thing comes in and then one thing comes out. All right, so you can't have one thing come in and two things come out, and you can't have one thing come in and nothing come out. So they had a few questions about a homework problem, then I went over another word problem, then I went over composition of functions, okay? So this is the word problem that they had questions about. It was the one on page 205 when you were making a box, okay? So let's make sure that we understand kind of how you make a box. All right, I did this for them in class, all right? So let me kind of make sure. All right, if I have a piece of paper that's a rectangle, if I were to tear a square out of every side, okay, so that'd be a square I tear out of that side. All right, so there it is. Then I'm going to tear a square out of the other sides that's the same size. Okay, so that's kind of what I did for them. All right, I went and tore the square kind of out of every side. All right, now, let me make sure that you kind of see that, I hope, a little bit. All right, now, let me do this real quick. Let me stop sharing the screen so you can see a little bit bigger. All right, so I've got my piece of paper, and all I'm going to do is like fold it. Okay, and I'm going to fold it. Now, it would be better if these were actual squares if I had measured them, and I didn't. All right, but do you see when I fold it up that I really do get a box like the one drawn in the book? Okay, now notice what happens. All right, the original paper was 18 all the way across. And I cut off an amount here and an amount here, the same amount. So we didn't know what it was, so we're going to call it X. And that's an X. So do you see that this length that's left would be 18 minus this X would be 18 minus 2X. So when I fold it up, that's the length of the side that's left on the box. Okay, so let me share the screen and kind of show it with you a second. Okay, let's see if we can find it. There we go. All right, so do you see that it was 18 from here all the way to here? So if I cut off X and I cut off X, I'm going to say 18 minus that X minus that X. So from, let's see if we can make an annotation. So from here to here, that's going to be the length of the box when I fold it up. All right, that's going to be 18 minus 2X. And the same thing happens on this side. It's 18 from here to here, but if I take off that X and I take off that X, this distance right here is going to be 18 minus 2X. So do you see that this I'm outlining is going to be the bottom of the box after I fold it up? So this side is 18 minus 2X, and that side is 18 minus 2X. And then when I fold it up, can you still see that, you know, this was X. So when I fold that up, that's actually how tall my box is. So that's the height of the box, so it's an X. So there's my formula for the volume of a box. Now, if you want to multiply it out and get like a polynomial, you could just leave it like that. And then the C part said, so what would be the volume if you took off 4? So we just plugged 4 in there for our X and got 400 square inches. That would be the volume that our box would hold, okay, if we took off that. So because this side would be 18, all right, if that was 4 and that was 4, that would mean I would take off 8, so that means that side would be 10 and that would be 10, and then it would be 4 tall. Okay, all right, so let me kind of clear these drawings. And let's kind of go look at the next one, okay? And this is a different kind of word problem that kind of used functions. All right, we talked about if you were going to decide you were going to make money, like maybe you decided that you were going to make some masks, okay? And you were going to sell those, all right? So if you were going to sell your mask maybe for, and this is not to do with this problem, this is what I talked about in class. Do you understand that how much money you charge for each mask would be your revenue? Your revenue is the money that's coming into your company. So if you decided you were going to sell these masks for $10 a piece and you sold 3 of them, $30 would come in. If you sold 5 of them, $50 would come in. If you sold 100 of them at $10 each, $1,000 would come in. So it's just how much you're selling them for times how many you're selling. That's what revenue is. How much you're selling them for times how many you're selling. But now think about it. You had to pay for the material like the elastic and the material and the beads or whatever. You had to pay for that. So the cost is what's going out. That's your bills. All right. And profit's what's left over. So it's the money coming in minus when you pay your bills, the money going out. What's left over is your profit. And so on page 206, they kind of gave you an example where you were selling things for $21.95. So it asked you on part B to do the revenue equation. So to do the revenue equation, all you're going to do is say the cost of each item, $21.95 times the number of items sold. We didn't know how many we were selling, so we put a variable there. So the revenue would be how many you sell times $21.95. So if you sold one, $21.95 would come into your company. If you sold 100, then $2,195 would come into your company. Well, now let's think about cost. Now, part of your cost depends on how many you're making. Like you have to go buy material for every one of those things to make it. But this right here is fixed cost. So fixed cost would be something like your electricity bill. It doesn't matter how many you make, you still got to pay to have the lights on, or your rent. Or it might be that you have to pay your workers every week, whether they actually work or not. So some cost, it doesn't matter how many you're making. So your cost is the sum of those two things. It's your fixed cost plus how much each one costs you times how many you're making. Okay? So again, we didn't know how many we were making and selling, so we call that X. So that's why ours went 1175 times X plus my 112,000. So look at that problem, number 84 on page 206, and read it. Like stop the video and pull it out and read it. And notice that you're charging $21.95 for each one. So that's why that would be the revenue equation. And then every one that you're making costs you $11.75 in materials. So you got to say how many you're making times that, and then add your fixed cost to it. So there's your cost. So what's your profit? Remember, the profit's the money coming in minus the money going out. So we just put our formula for revenue in place of R, minus we put our formula for cost in place of C, and then we distributed that minus. And that was our profit equation. Now, we went a little further than the book. I asked them, what would it mean if your company, what does it mean to break even? So do you understand that breaking even means you don't make any money and you don't lose any money? So what that means is the money coming in must be exactly the same as the money going out. So I asked them, how many will we have to make and sell to break even on this problem? So we set our R equal to our C. So remember, that was our formula for R, and then that was our formula for C. And then we solved that. So we subtracted 11 and 9500ths X from both sides. And so this X minus this X gave us 10.2X. And then we had 112,000. So we divided both sides by 10.2, and we'd have to make and sell about 10,980 of these things to break even. So in the real world, that's what you want to do. I mean, if you don't think you can sell that many, you don't need to start your business. And if you think I can only make and sell 11,000, you don't want to do all that work for like 20 bucks. So, you know, when you're deciding if you want to start a business, you need to figure out what's it going to take to break even and see if you can do a good bit more than that, because you want to make some profit. Okay. So neither one of these were really anything new. They were just applying functions. So the one little new thing we went over is something called composition of functions. So composition of functions, when you have a function hooked to another function. So the example I gave them in class was, if I work for Nissan, do I make the whole car by myself? No. So, you know, you work in like an assembly line. So maybe I put the front doors on, and maybe you are after me and you put the back doors on. So does it make sense that what I end with is what you start with? So that's what composition of functions is. Something comes into the first one, and something, when it comes out of the first one, it goes into the second one. So the composition looks like a little circle. So when they do it, it looks like this little circle that says G composed with F of X, and that one says F composed with G of X. So what I told them in class was it's really better to write it this way than that way. Now notice the order is the same. G is first both times and F is second. But see, same thing, F is first and G is second. But the reason that these are a better way of writing them is you're used to doing parentheses inside of other parentheses. So do you work inside out or do you work outside in? And you remember, you always work from inside out. So if they told you to do G composed with F of 2 and you wrote it like this, that tells you to put 2 in F first. So you put your 2 in your F function. So now what does your F function do? See, your F function is going to square what you put in and add 1. So if I put 2 in the F function, it's going to square that 2 and get 4 and add 1 and get 5. So that's why 5 fell out. So F of 2 is just 5. Now what's going to happen to that 5? See, now that 5 goes into G. See, that 5 goes into G. Well, what's G going to do? It's going to take whatever you put in it and it's going to multiply it by 3. So when you multiply 5 by 3, 15 falls out. So that's why the final answer is 15. Now, what if instead you did F composed with G of 2? Now, what's different about this one and this one is what it goes into first. See, now 2 goes into the G first. So if 2 goes into the G, look what it does. It takes that 2 and it multiplies it by 3 when it goes in G, so 6 would come out. And that 6 would fall into that function of F. So now the 6 goes into F. Remember, what does that F function do? It squares whatever goes in and adds 1. So when it squares that 6, it's going to get 36, and when it adds 1, it gets 37. So if you have to do composition of functions, rewrite them like this, and then this one goes inside of that, and then whatever that answer is goes inside of the next one. Okay? So if you have any trouble, I put some homework up. Most of the homework is not anything new. The composition's not really on the new homework. It's just some problems. Basically, let me stop this share. Okay, it's just some problems, kind of like what you had for homework for today. So hope you're not feeling bad. Hope you're well. If you need some help, just make sure that you come see me. I mean, well, actually, you can't come see me, but you can email me and we'll meet one-on-one by Zoom. Okay.